Radioactive waste is perceived as being one of the most challenging issues. European scientists are therefore concentrating their efforts in this field, both in research on reducing the actual amount of nuclear waste, as well as on implementing solutions for the safe disposal of all types of radioactive waste, in particular high-level and long-lived waste. At SCK-CEN in Mol, Belgian scientists are investigating new ways to reduce the toxicity of spent fuel. Their research aims to transform the long-lived components of the spent fuel of reactors into shorter-lived or non-radioactive isotopes. The procedure is known as partitioning and transmutation.
Partitioning is simply separating the different elements from each other. Then we get the uranium apart, plutonium separated, and also the minor actinide separated, and the fission products. And we can even go further on by taking some of the particular fission product separated from the bulk of the fission product that we are creating.
Technically, scientists have demonstrated at the laboratory scale that partitioning and transmutation can work. So far, only small quantities of radioactive isotopes, so-called minor actinides, have been treated. In the future, such procedures could reduce the length of time over which disposed waste remains radioactive.
We take indeed that example of the iodine-129 isotope, which has a half-life time of 15 million years, if I remember. And actually, when we say we transmute it, means that we will be bombarding it with neutrons. We transform it into iodine-130, which then has a half-life time of only 12 hours.
Research on advanced reprocessing contributes to the development of so-called closed fuel cycles for new fast neutron reactor systems. These future Generation 4 reactors offer the potential of vastly increased sustainability while producing much less high-level waste for disposal. Regardless of the success of such techniques, there will always be quantities of high-level and long-lived waste to be disposed of. The consensus is that the only safe long-term management option is deep geological disposal in stable rock formations. The first geological repositories are already on the way. One of the most advanced national programs can be found in Finland, in the municipality of Eurajoki. Here at Onkalo, the world's first deep geological repository for high-level radioactive waste is under construction.
We started this work in 2004 with the start of construction, but right at the same time we also started the characterization activities here, which now have been going on for 5 years already. So we know a lot about the rock from the depth already. We are there at the depth of 300 meters, more or less. And now we are approaching the actual host rock of the repository. And of course, that's the most important part of it.
The concept is based on the use of multiple barriers, which ensure that harmful quantities of radioactive material cannot leak into the host rock and eventually return to the biosphere, even over very long timescales. Disposal operations could start by 2020. By 2100, the repository could be full, access routes would be backfilled and sealed, ensuring the waste remains isolated for as long as the radioactive hazard exists.